Hi, everyone. Let's take a look at the following example. Determine the domain of the inverse of f of x, given f of x is negative 2x plus 13, defined on the domain x is an element of real numbers, where x is in between negative 11 and 3 inclusive. Step 1. Draw a diagram. If you think about this carefully, again, you want to start with f of x, then look at the inverse, then find the domain. So we're not thinking specifically f of x equal to negative 2x plus 13. Because if you think about it in terms of the general form, then you start at 13 and you look at the slope, which is negative 2. So you go down by 2, right by 1, and you can keep going. But the problem is this is not what we're looking at. We have to confine this in the given domain. So you want to find out what happens when x is negative 11, what happens when x is 3. So let's go back. So if you think about x equals to negative 11, f of negative 11 equals to negative 2 times negative 11 plus 13. Again, you can grab a calculator, you can do mental math. That's going to be 22 plus 13, which equals to 35. So one location is going to be negative 11, 35. Likewise, if you think about x equal to 3, which is the second value, you can plug it back in, and f of 3 is going to be negative 2 times 3 plus 13. And again, if you think about this, 13 minus 6 is going to be 7. So 3, 7 is the second location. So I'm going to go back and redo this diagram in such a way that I can find the inverse. So one more time. Let's take a look. So if I go back and I look at this, let's pretend this is 35. Let's give you a relatively accurate scale. So negative 11. So let's say this is going to be, let's divide this into 7 parts. So negative 11 and 35 could be, roughly speaking, somewhere here. It's not perfect, but it's good enough for the demonstration here. 3, 7 is going to be somewhere here. Okay, so I can connect them, right? And this is basically, again, that original function, negative 2x plus 13, except I'm focusing between x is negative 11 and 13 inclusive. So if I take a different color now and I find the inverse, again, remember, inverse means you swap x and y. So xy becomes yx. So now negative 11, 35 becomes 35 negative 11, which could be somewhere here. So let me label this 35 negative 11. 3, 7 becomes 7, 3, which could be, roughly speaking, somewhere there. And I connect them. And again, to double check your work, you can always draw this mirror reflection at y equal to x, so that graphically you can say, oh, I get it, this makes sense. So now you go back to the question, right? And the question says, determine the domain of the inverse. So again, in this same color, let me just write down the inverse. So we haven't even found the inverse algebraically, and we don't have to, because this is kind of the dual mindset that I would like you to activate. So when I think about the domain now of the inverse, well, it's going to be domain, open curly bracket, x is an element of real numbers such that x is in between 7 and 35. So again, you put 7, you put 35, and you put the equal sign to show that x is in between 7 and 35 inclusive. If you find this video meaningful, it's adding value to your math life, please comment, like, share, and subscribe. I hope this makes sense.